In this video, we will look at section 1.3. I've split it up into a couple of different pieces. So part 1 is on just the basics of radicals and the concept. You can either just follow along here or print out the sheet that I posted. So anatomy of a radical is what I want to talk about first in that first line there. So we have the nth root of a equals a to the 1 over n. So you can always write the root method as a fractional exponent, and they mean the same thing. So for example, if I had a to the 1/2, that would be the same as writing square root of a. If I had a to the 1/5, for instance, that would be the same as writing the 5th root. So I wrote a square root symbol and I put a 5 in that little triangle. That's called the index. So it would be the 5th root of a. So those are equivalent things to say. If I want to put numbers in there, I would, for example, this principal root problem here that I have written square root of 25, that I could write as 25 raised to the 1/2. Okay, and what that means is I'm trying to look at what two factors multiplied together will give me 25. So I want to talk about the principal root here for a moment. Principal root means if I have, for instance, the square root of 25, this is just an expression. It's not an equation where I'm solving for something. So I would just crunch the numbers and I just get the positive root. And I'll show you how that's different from when we're solving. So here, the square root of 25, I could write 25 as 5 squared. And then if I took and divided the index there of 2 into the power, I would just be left with 5. There's no way -5 is going to be an answer. But if I compare to this x squared equals 25, if I'm solving, then I would have to say, okay, I'm going to take the square root, or this square root of both sides, or I'd be like raising it to a 1/2 power, and that's where I'm putting like parentheses around, and I'm actually taking the square root of x squared on the left hand side and the square root of 25 on the right hand side. Now there's two possible answers that would give me the value of x. So I would end up with x equals plus or minus square root of 25, which then equals plus or minus 5, or I could write it as -5 or positive 5 as my answer. So that's the difference. You've probably done that before, especially using the square root method to solve or the quadratic formula. So I just want to clarify, when we're actually just taking the value of the number, that plus or minus is kind of outside that square root of 25. So that leaves us with a principle to think of too. I'll just jot down off to the right that if we just have an expression where we have, and I'll write it up here with the principal root, where we have square root of x squared, and we're just crunching the numbers, and we're not solving for anything, then that actually is just going to be the absolute value of x. We wouldn't have the negative version. I've also put a link there to some notes on that if you're curious about how that's proven out. One other thing I want to talk about, back at the top of the page where I talk about anatomy of a radical, and we have, I'm just going to make this a little bigger here, we have the nth root of a, equals a to the 1 over n. So that's written on your paper. And I just want to label some of the things. This nth root, what we call that is the index that I referred to earlier. So you might want to label that. This is labeled all in your book as well. This symbol here, looks like it's a square root symbol. It's called the radical sign. And the radicand. So is what's underneath that square root symbol or root symbol, also called the radical sign. So this is the a of this nth root of a is called the radicand. So you may be familiar with this. The whole thing right here is called a radical expression, nth root of a. It's not an equation. I've kind of made it into one, writing the rule, how it's equivalent to a to the 1 over n. That's just a different version. Now let's just take a look briefly further down the page. We have negative radicands. We can take odd roots of negative radicands. We cannot take even roots of negative radicands. In the scope of this course, we deal with real numbers only. So for this example, I have square root of -4. And I have to think what times what would give me -4 under there. Well, if off to the right I'm writing 2 squared, well, that would be 4. Even if I tried -2 squared with the parentheses around it, I'd still get a +4. The only way I would get negative is if I'm using imaginary numbers, and that's out of the scope of our course. So for an answer, what you would write is DNE is pretty typical for what you're going to put into the electronic homework, or you can write that on a test. You could write undefined. And you could use the symbol, a big circle with a line through it, meaning empty set or null set. However, in the next example underneath, we have the cube root of -8. So that one, I can think, well, I would have 2 cubed is going to give me 8. So 2 times 2 times 2 would give me a +8. But if I had -2, even in parentheses, cubed, that would be -2 times -2 times -2, resulting in that -8. So I could say my answer is -2 for that cube root of -8. So we can have we can find a real answer for roots when they have odd indexes or indices. So even though we would always have to have a positive value, or it's undefined. Okay, now moving down the page to where it says simplifying radicals, rules to know. First rule is none of the factors of the radicand can be written as powers greater than or equal to the index. So you're basically dividing the index into the power of the exponent. And whatever's left over, if it doesn't divide all the way in evenly, then you're going to leave that underneath. Otherwise, there shouldn't be any multiples of that index left. Number 2, there are no fractions under the radical sign. So we need to simplify to undo that. And number 3, we'll get to those later, but no radicals in the denominator. So we need to rationalize the denominator is to get it in simplest form. There are some cases where you don't do that later on in higher math, but for now we're going to work on simplifying in that method, but that'll come in the next video. Properties. Product property is the nth root of AB. So AB is my radicand. I have a product in there. So I can split those factors apart, and I can write that as equivalent to nth root of A times nth root of B. I also have a quotient property saying that when I'm dividing, I can split them up in the same manner. Nth root of a over b is equal to nth root of a divided by nth root of b in the denominator. And below I have some examples. So here we have the square root of 32. So my index is 2. So I want to be thinking about what times what is going to give me some perfect squares to work with. You could also, so you could do that pretty quickly on this one. You could write that as 16 times 2. And you might recognize right off the bat that 16, the square root of 16, can be written as 4. So here I have square root of 16 times 2 equals square root of 16 times square root of 2. I've used my property. Now I'm going to take this square root of 16, and that comes out to 4, and I'm left with square root of 2 under the radical sign. Now, if you didn't know right off the bat, so if you didn't know right away that square root of 32 would break down to 16 times 2, I've written out a different method here. You could break it down into a product of its primes, and you would end up as square root of 2 to the 5th, which breaks down to square root of 2 squared times square root of 2 squared times square root of 2, which would then give us 2 times square root of 2, which equals 4 square root of 2. That's the same answer as we got above. Just a little bit longer method, but if you have trouble recognizing the perfect squares and making factors that work out nicely, you can break it down to a product of its primes and put it in exponent form. Now, I would like you to stop the video and do the next problem, which is the cube root of 40. That's try it. So I'm going to write here, try it right above. And go ahead and pause, and I'll write out the answer, and then you can check it. So the answer for that comes out to be 2 times the cube root of 5. The next problem is the square root of 75x cubed. So we want to figure out how to break down that 75 first. So I would think of that as 25 times 3, because I know 25 is a perfect square. Again, you can use prime factorization to help you out if you're stuck with that. And the x cubed, I'm looking for perfect squares, so I'm going to write x squared, and then I know the leftovers would have to be x to the first. So if I want to pull out my perfect squares, I could rewrite that as square root of 25 times square root of 3 times square root of x squared times square root of x. And my perfect squares would be the square root of 25 gives me 5. The square root of x squared gives me the x. And left under the radical sign as the radicand would be the 3x. And that would be my final answer. 5x times the square root of 3x. Works the same way in these next couple of problems that are, they have fractions. I'd like you to try those on your own. Just pause the video and then I'll write out the steps. Okay, so here is the first one, square root of 4 divided by 25. So that's a fraction 4/25. So we can use our property and we split it up. We just write square root of 4 in the numerator and square root of 25 in the denominator, and then we just crunch the numbers. So we end up with 2 in the numerator and 5 in the denominator for that problem. The next one, we have the square root of 8x squared in the numerator, all divided by square root of 9. Again, you can just split it up into two separate the numerator and the denominator. So I have square root of x squared in the numerator and square root of 9 in the denominator. And then I break it down. The 8 can break down to square root of 4 times 2. So I've written those right there. And then the x squared is just square root of x squared, all divided by square root of 9. So the square root of 4 we know would be 2. Square root of x squared is x. And the square root of 2 I cannot break down any further, so I just leave it as that. So I have that in the entire numerator, all divided by 3. So my final answer is 2x times square root of 2, all divided by 3 in the denominator. And that's it for part 1. Thank you for watching.